Hi, we're working with the MT Pro again today, and I want to show you guys how to use channel 9 or our trigger channel or our sync channel, and how we're going to make that work for us. So the first thing I want to go over is how it automatically will set this up. So you see this little box here. If that's clicked like that, that shows us that it is set in auto mode. So when we start this file, it's going to automatically look for a compatible signal and then scale it properly to use for our sync. And it works really well. I've been very impressed with it. The only problem that I've run into is sometimes it'll have issues with scaling like this, and I'll show you this here. So let's just turn off, take channel 9, we're going to move it up. I'm going to come turn on the markings and the framework. So the framework shows our voltage limits on each end of the scale, and you can see how most of these, we'll go all the way back to the beginning too. So you can see most of these here, the larger spikes are cylinder 1 firing. This is a dual fire coil, and the little spikes are the opposite cylinder firing, which I believe is cylinder 4, but I'm not sure. But you can see cylinder 1 is scaled to leave the voltage range, and when it does go past the voltage range, that's how it determines the sync point. So you can think of it digitally as anything within the framework is 0. Anything outside of the framework is 1, and 1 is our sync. So you can think of this as a digital channel. Everything outside of the framework becomes 1, everything inside of the framework is 0. And I want to show you, so let's get rid of this. I want to show you, I have that unclicked right now. When I open a file that was recorded with the auto setting will be clicked, and also when you start the file, it'll automatically generate that signal right off the bat like that. So we know it's already set up, it's already dialed in, the auto setting worked, and we're happy. If we were to come in here and let's tab up a little bit and turn our framework back on. So if we were to come in here and we were getting false cylinders, like say the weaker signal was leaving the framework and counting, we may have to come in here and adjust our voltage or adjust our scaling. But in this case, we're okay, even though it left a little bit. Once it dials in, it stays pretty accurate, even if, like, say, during this snap throttle event here, where it gets all nasty, even during a potential issue, it will continue to use that as a time reference. So it's really, really pretty awesome. It seems to work really well. But what happens if you want to do a cranking event and you can't be cranking the vehicle and start the file to make the auto sync work, right? To set up the auto trigger. So let me show you how we overcome that. So we can reverse engineer that based on this. Once we understand that everything leaving the framework is 1 and everything in the framework is 0, we can set this up manually and get reliable results. And let me open up a file where we did that. So here is a file that I did this manually. You can see this is a cranking waveform. This is a just a battery voltage trace in order to measure relative compression. Even though there's not a lot of definition in this signal, this program can do this for us. But that's for another video for another time. So today, let's just move this up out of our way, and then we're going to move channel 9 up to the middle, bring that down, and then again, let's turn on our framework so we can see where these lines are. So, and actually, let's bring that up a little bit so you can see the framework on the bottom as well. So the bottom here and the top here. So when we zoom in, you can see here is our coil trigger. So this is the PCM coil trigger. This is our dwell time of our coil, and then when it's shut off, the coil fires. And so that's our number one sync. And you can see we have our scale set on 3 volts because this is a 5-volt square wave. When the voltage leaves the framework, it becomes a 1 in the mind of the sync. So remember, as long as you're creating a pulse that's going to leave the framework regularly, it should create a reasonable sync. I've tested this out quite a little bit. It works really well. You do have to have a consistent sync over a consistent period of time to run these tests. So 15 seconds works really well. You want to have at least 15 seconds of crank time or whatever you're trying to do. But you can see that's the most important thing to understand, is everything within the framework counts as 0, and everything outside of the framework is going to count as a 1. And once it sees the 1, every regular interval, it's going to determine that that is the sync you want to use. And it works really well. I'm pretty happy with it. But sometimes, say we had this set at 4 volts, it might not be enough. I've found that about 30% or more out of the framework works the best. So I'll shoot for about half the signal to about 30% to about 50% of the signal outside of the framework works the best, as long as the signal's not too noisy. And that seems to work really well. So I hope this helps. I find this really extremely useful. But do some messing around. It's really nice to get the trigger to work so you can perform the analysis tests. So this is definitely worth working with a little bit and getting used to. Of course, you can still pick any channel, set up a manual trigger, and set things up that way, but that will not work very well with the analysis test. So it's nice to just use the trigger channel the way it was intended, and understanding that it is essentially a digital channel. So even though it will create a waveform, and in a pinch you could use it to create a waveform, its number one purpose is to create a digital signal for a sync. And it does that by judging whatever leaves the framework by the voltage you set. And that determines, as soon as it leaves the framework, that is a 1 instead of a 0, and everything in the framework is a 0. And that's the digital representation of the sync. So every time it sees this, it goes, okay, well, this is a point in time. When we see a 1, we know that's our sync. And you can see how that works. And it does, like I said, it's pretty reliable. I've had really good luck with it. The other thing I wanted to show you in this video is when the analysis tests are open, sometimes it's nice to move these windows around. So when you grab this window and you go to move it, you can see there's these little boxes here, there, and there. Well, you can get this on every part of the screen in a split screen mode, like that. Or you can either go right to the middle here or drag it up and put it right next to the oscilloscope, and now they're on tabs, so you can go back and forth too. It all depends on how you want to use it and how much you need to see each section. And some of the working spaces have this automatically set up, and if you don't like it, you can always just change it, and you can even adjust like your window this way. You can click on these to bring your window back and forth. So this is really a really nice customizable program. You can have multiple windows up if you really just, you have a huge screen and you can get away with all that. But I do this on a laptop, so I like a relatively uncrowded screen, so I'll usually run them like this in tab mode. And then, occasionally, especially with the power circuits one, I will actually I like it like this. So then I can see my waveform to the right and still get everything set up over here if I want. But anyway, that's all we're going to go over today. I just wanted to go over some more basics, make your life a little easier. If you have any questions, comments, or anything that you'd like to see this program do, just leave it in the comments, and I'll do my best to make a video on it so you can, make it do what you want to make it do. Or if you're trying to make it do something and you're not quite sure how to make it do that, ask in the comments, and I'll do my best to help you out and make sure that you can make this program and tool do what you need it to. So thanks for watching. Have a great day.